To solve polynomial equations, we depend on what's called the zero product property, and that's in your notes. Meaning that if I'm multiplying any two values together and the answer is 0, that means that one of the two values has to be 0. And that's what's true when we're solving these particular types of equations. Please make sure that you read all of the steps as far as solving these equations so that you understand, because the most important thing is that the equations are set equal to 0. If they are not set equal to 0, you will have to rearrange them so that they become set equal to 0. So let's take a look at the first problem here. 2c minus 1 times c plus 4 quantity squared equals 0. So what that means because these three are multiplied together and they equal 0, that means at least one of them is equal to 0. So what we do is say, okay, well, if 2c minus 1 is equal to 0, that means 2c is equal to 1, so c is equal to a half. Or c plus 4 is equal to 0. That means c is equal to negative 4. Or c plus 4 is equal to 0, so c is equal to negative 4. Mrs. Busselmeyer, you did the same thing twice. Yes, I did, because it shows up here. The fact that we've got c equal to negative 4 twice is what we call a double root. The solution to this is c equals 1/2, or negative 4 double root, and I just write dr for double root. If you neglect this double root, your answer is not correct. You have to write down that it is a double root. Take a look at the next one. We have x minus 2 squared, and then here, that's a difference of squares. Remember when I told you you had to know how to factor? This is why. So our difference of squares is x minus 3, x plus 3. So one of these four would then have to be equal to 0. So these are the four solutions. You've got a double root here, but notice 3 and negative 3, that's not a double root. So your solutions, negative 3, 3, 2 double root. And I would prefer to see all of these values from smallest to largest with all your double roots listed at the end. So here's our next one. Notice that it's breaking the first rule. It is not set equal to 0. So in order to make this equal to 0, we simply subtract 18 from both sides. And we end up with y squared plus 7y minus 18 is equal to 0. From here, you have to factor. We've got a quadratic, so we factor that quadratic and make sure it's still equal to 0. So remember those rules of factoring. This minus sign tells me that I've got a plus and a minus in these two. The plus sign here tells me that this value will be larger than this value. So two numbers that multiply to 18 would be like, say, 9 and 2, and positive 9, negative 2 equals 7. So just like before, either y plus 9 will be equal to 0, or y minus 2 will be equal to 0. So there are your solutions. Here's another one. Now maybe your first inclination is to subtract 3r from both sides. I don't like to do that. I want the coefficient on my quadratic term, the term that's squared, to be positive. So what I do is I subtract 10r from both sides, and I subtract 8 from both sides. So that becomes 3r squared minus 10r minus 8. Again, it's quadratic. (3r) and r. This means I've got a positive and a negative. I don't know where they go, so I just sort of put them where I think they might go and see if I can figure it out from there. And then I start choosing factors of 8. So I might try, we'll make that. So 4 and 2. If I multiply these, 3r times 2 is 6r minus 4r. That's not negative 10r. So I'll erase. What if I switched them around? What if I made this a 4 and that a 2? Well, that's 12r minus 2 is negative 10r. That's getting closer. What if I make that a plus and this a minus? That'd be negative 12r plus 2r. That's my negative 10r. So that's how I will work through something like this. Let me clean it up. So I know that 3r plus 2 has to equal 0. Or r minus 4 has to equal 0. So my solutions, negative 2/3 and 4. All right, so we actually did this problem by hand, and we know that we've got roots that are 2, which is a double root, negative 3, and positive 3. So the question is, what does this look like if I graph it? So in order to graph these, go to the y equals in your calculator. And you'll actually just enter exactly what you see is equal to 0. So x minus 2 squared times x squared minus 9. And as long as your window is set to a standard viewing window, you can graph it. And so we've got this sort of thing happening. And we already know what the solutions are, but we can find them by going to second trace. And what I'm looking for is a 0. So I'll select number 2. I'm going to start with this one over here. Okay, it asks for left boundary, so I need my cursor to be to the left of that 0. So here's a value to the left. I know it's to the left because y is 31.95. If I move to the right, it moves down here. So somewhere to the left and hit enter. And then if I move to the right, I hit enter again. You can make a guess if you need to. Probably won't be too easy with this. Hit enter, and I see that I've got a 0 at negative 3. I can do this 0 on the other side the same way. Some left boundary, you actually can just hit enter. You got to move to the right of that 0. I'm looking at my y values here. See how they're getting larger? Now they're where I can see them. So I am to the right of this last 0, which should be 3. Then it asks me to make a guess, so I might just move it to right there as my guess and hit enter, and that 0 is at 3. Now I'm going to zoom in a little bit. I'm actually going to do what's called a zoom box, which means I'm going to draw a box around what I want to see a little bit closer. Hit enter, and then you draw a box. That was our 0 at 2. That was our double root. So we can second trace, look for the 0, something to the left, enter, something to the right, enter, and enter again. Ah, it says no sign change. Interesting. Okay, so that's actually a glitch in the graph. But what I want you to notice is that at this double root, it just touches the x-axis. Whereas if you looked at the root at 3, let me zoom out just a little bit. The root at 3 actually crosses the x-axis. A double root just bounces.